Yes, I'm on page 60 of the slides, just going backtracking a little. So we concretize a few elementary concepts in Python programming to get you started programming with sets and a simple concept. Why am I using sets? I want to use the simplest idea you have to teach you Python. If you have a more advanced idea, I will use that advanced idea to. You can teach Python at any level. So it depends on programming. The person must know something. So it is from what he knows. So what I have concentrated on here, I concentrated on our attempt to use Python to answer SSCE questions that you already know very well how to answer. So by the time we can now program to answer them, that will help you to understand programming a little bit. It is not that you cannot solve those things some other way, but we are using them to learn. That is not two important issues. You do not have to understand everything in Python code to obtain useful results. For example, I give you a code that is working. If you can type that code in and get the result that I get, you are learning something. It may not be obvious. You are actually learning something. I can challenge you that if you can type in 200 programs that are fully working, you are already programming. If you can type it in, get the results that the person who wrote them got, and you type them in, you got the same results. I call it tedious task of typing it in, going through a debugger. That is a lot of programming experience that you are having. Programming is blood, sweat, and tears. It is blood, sweat, and tears. It is very often pattern matching. You see some patterns, they stay in your mind, and you can repeat those patterns even when you do not understand them fully. So, before delving into this note, the number one important is that you do not have to understand everything in my Python code to obtain useful results. Number two, when you do not understand some things, take note of the patterns. Sometimes the patterns in programming code will be sufficient to get useful results. Sometimes. Full understanding is our goal. We want you to fully understand the code, be able to fully read another person's code, be able to fully understand what anybody is expressing through code. But refusing to move until you attain full understanding is not optimal. Somebody who will become a very good programmer and a very good user of computer-aided graphics using scripting is not somebody who waited until they understood the full thing before starting. If you do that, it's already too late. You would have wasted a lot of time. But when you do not understand, check what the patterns are. It is even the best programmer does not understand everything in the code. There are certain things you just take because you are given and they follow a particular pattern. So let me just make that very clear. So the first thing we started looking at last week were identifiers, assignments, and sets. Identifiers. If you look at there are four statements in this page. And those four statements have equal sign that you are familiar with. Unfortunately, I need to tell you that the equality sign in programming do not carry the same meaning as your arithmetic equality. For example, if I say x is equal to 2, that means 2 is equal to x. Whereas x is equal to 2 will be a correct programming statement. 2 is equal to x will give you an error because that equality you are seeing in computing is not equality. It is not equality. It is an assignment. There's a difference between an assignment and an equality. When equality is used in programming, the equality that is equivalent to your own understanding of equality is double equal. If you see equality repeated, that equality is the arithmetic equality that you know. So when you want the arithmetic equality you know, in programming, it is going to be double so as to distinguish it from the equality that is in assignment. Just know the first thing, this is an error made in 1940s when programming started, and programmers refused to correct it. What that equality ought to be is like a backward arrow. If they did a backward arrow, that is what you have on the right, push it inside what you have on the left. That is what it really means. So the equality sign you see in these statements do not carry the same meaning as the arithmetic equality you are used to. They are assignment statements. Once you understand what an assignment statement is, you are already on your way into programming. Statements that are assignment statements contain three elements. There are three elements in an assignment statement. There is the expression on the right-hand side. It is an expression or a value or an identifier, anything that can be computed and that can have a value can be placed on the right-hand side. On the left-hand side, there must be something that is an identifier. That is only an identifier that can stay on the left-hand side. Nothing else would be acceptable on the left-hand side. And in between them, there is an arithmetic assignment. That is the equal sign separating them. Read it like this. Compute the expression of value on the right-hand side. Assign the identifier on the left-hand side as a reference to the result. You compute what is on the right-hand side. Once you have finished computing it and it has a value, place that value in what is on the left. In these particular cases here, you are just creating and packing sets. The first one, you pack numbers into the set. The second one, you pack some numbers to the set. The third one, you pack some lowercase alphabets into the set. And the last one, you pack some uppercase alphabet into the set. That's all. From this point on, if you say pos int, it means that set you have on the right-hand side. Anytime. So instead, what you are doing is that instead of carrying that whole load, you already have a reference that identifies them. That's why you call it an identifier. Arithmetic assignments here are simple because there is no expression to evaluate on the right-hand side. Instead, in each case, we simply have a packed set with elements as we have seen previously. The statements therefore simply assign sets on the right-hand side to the properly named identifiers on the left-hand side. Once such referencing is established, any use of those identifiers beyond that logical point in the program refers to the assigned result, that is, in this case, the packed set on the right-hand side. So if you say alpha up, it means that whole set, A, B, C, D, or the uppercase. If you mean alpha low, it means the same thing in the lowercase. If you mean numerical Arabic, you mean 0 to 9. If you mean pos int, you mean 0 to 20 in this program. From that point on, unless you change it, thou shalt not use a keyword as identifier. The only serious rule in identifier is that you should avoid keywords. But now, I've not told you what keywords are, and I will not do so until the end of these slides. Just know that there are certain things that are forbidden that you are not to use as identifiers. Apart from that, once you start with an alphabetic letter, anything goes, as long as you do not use exclamation mark, pound sign, at sign, percentage, and some of those things are not allowed. Star, asterisk, bracket. If you are not doing any of those things, you can use anything from A, B, C to Z, uppercase or lowercase, numbers 0 to 9, as many of them as possible. Your identifier should be a single word, no space. If you really want a space, you can use underscore sign, not minus. Minus will not help you. Minus is going to cause you trouble. So you can use underscore to really create a blank space, because blank spaces are not allowed. You create identifier names as you like. How long can they be? I don't even know if there's any real limit. Just make sure you just do something that is sensible. You shouldn't be naming all your identifiers Shokoloko, Bangoshe, or Tiptana Todanin, or Tuktoyatuk, or something. Just use something simple that you can remember, and because you must remember the identifier's name exactly. If where you use uppercase, you must use uppercase. You cannot, you will see, we talk about that later. The first character must be a member of the half inch. That is, it must be A, B, C, D to Z, or ABCD to Z uppercase. Any element in the numerics can occupy other positions. Numbers can occupy other positions, and use as many characters as reasonable. There are no real limitations as to how long they can be. Identifiers we use are case sensitive. So pos int, pos int, pos int, pos int, they all look the same, but to Python, they are all different identifiers. They are all different. You are not allowed spaces or special characters in the name of identifiers. Use what you'll be able to remember, as you will need to recall the identified result or objects later. It must not be a keyword. And yet, is it not frustrating? I still haven't told you what keywords are. You will be getting them small by small, but at the end, I will give you the list of keywords. Take a program like this. In a full program that you are to explore here, there are several words of interest. These are keywords. For instance, you see in this program, you see the word true with a capital T, the word in, the word false, the word for, the word if, the word else, the word break, the word print. All those things are keywords. Usually, most keywords are lowercase except true and false here. So if most of the time when your identifier has upper and lower, you can almost be sure you are not using an identifier. So if you want to use if you use capital I plus the lowercase f, it's no longer a keyword. You can use that as identifier if you are crazy enough to want it so. I would not do that. I don't like playing with fire. A keyword has a predetermined meaning in Python code. It may only be used in that context. It may only be used in the context of its predetermined meaning. The numbers in the sets are numeric. They are numeric constants. The quoted letters are strings. So, like in alpha low, you can see all the things there. They are strings. And then the other ones are numbers. Now, the question comes, what if you make a number in quote? Like suppose you have 25 and you put a quote before and after it. Is it still a number? It is no longer a number, because you cannot use that 25 that you are put in quotes and add 3 to it. It will not understand because it is already treating it as a non-number. So you have to be careful, because the operations you can perform depends on how Python interprets what you have typed in. Like I told you earlier, that the set inside Python is almost the same as the mathematical set. Then this morning, as I was preparing for this class, I was just asking myself, can you name an example of where they are not the same? This is an example. You see in this, if I ask you to write the union of two sets in mathematics, you will say A union B. Union is one big U. And usually the name of the sets are either A or B or C or D. Where here is the difference. In programming, in Python, you usually use an identifier to represent the set. And then when you want to say alpha low union alpha up, that syntax where you write alpha low dot and you type union, that union there is a keyword, and it has to be in a bracket with alpha up. That's how you write A union B or alpha low union alpha up. That's how you write it. If you want an intersection, you say alpha low dot intersection alpha up. So those are the differences. Apart from that, they're almost the same. So if you are a serious member of this class, you ought to have typed this code in, and you ought to have gotten some result from it. If you have not done so, and you are in today's class, you are cheating yourself, and you are not preparing to do well in this course. If you are preparing to do well, you should practice. I gave you 200 pages. I want you to go as far as you can. Just do some things. But if you don't practice even the most elementary ones, you cannot sit in class, listen to me, and understand. The only thing you can understand are the things you do. You understand things because you do them. You don't understand things because you hear them. That's a fundamental theory in pedagogy, and it is my own experience in life. The things I know in programming or in graphics are things I have done. Anything I have not done, I don't know them. So you will not also be able to ask good questions in the class. But I still encourage you to go to the chat room. As far as I remember, I responded to virtually all the questions in the chat last week. The ones I didn't respond to are either questions that have already been responded to by me in another place or by somebody else that I think there's no need for me to repeat the answer. So if you have difficulties, you have questions, you can go to the chat room during the break time, which will be 15 to 20 minutes. I will go to the chat room and try as much as I can to respond to whatever you have typed there. So if you have problems, you have questions, you have queries, you have things you don't understand, you have any issue, you have something to share, go to the chat room, and what you put in the chat room, we record it, and we are going to give you grades for being present in the chat room and for participating in the class. A keyword has a predetermined meaning in Python code. It may only be used in that context. The numbers in the set are numeric. The quoted letters are strings. Apart from keywords, another kind of word-like token of interest are identifiers. We have talked about that. In these codes, the identifiers are post-int, num arab, alpha low, alpha up, alpha eng, alpha num eng, true false, are all identifiers. In your own programs, you are the person that will create, most of the time, you create the identifiers if you are the person who wrote the program. If somebody else wrote the program and you are just using it, you are using the identifiers he created. So that is a different thing. And in programming, whether in Python course here or in FreeCAD tomorrow, we are going to be using application programmers interfaces. And when we are using application programmers interfaces, what it means in simplest terms is that we are using programs written by another person to augment our work. So the other person write the program that does the heavy lifting. We are just using his program and arranging it to do our work. It's just like you are building a house. Somebody has already built a wall. You just take that wall, you mount it. Somebody has already done a slab. You just take that slab, you mount it. So the heavy lifting has been done by somebody else. It is for you now to know how to mount them and then get your final result. So but if you are writing the program yourself, it is you that will create the identifiers. Like all the identifiers you see on this page were created by me. Need for literary strings. Anytime you want to use a literary string in your program, the following rules must be observed. Place your string in quotes. If you do not, the Python interpreter assumes what you have written is either a keyword or an identifier, referring to a place in memory. An identifier refers to a space in memory that has been prepared to receive the answer that the identifier is assigned in the assignment statement. You are allowed single or double quotes as you like, but be consistent. You cannot open with a double quote and pair it with a single quote or vice versa. Obey the rules and your code will be correctly interpreted. Observe, in this particular code fragment here, observe that that after the colon ending the first statement, everything pertaining to the head, everything there is indented. Those indentations are not optional. They are specific and they are strict. This statement you are seeing here is what we call a compound statement. This compound statement has four keywords: for, if, else, break. All those are keywords and it is a for loop. In this for loop, the entire thing below the for is called the suite of the for loop. And because people here called suit, I just had to go on the web to search for the correct spelling and pronunciation. The correct spelling is S-U-I-T-E. S-U-I-T-E. That's what it is. And it is pronounced sweet, just like the sweet you lick or you give to little children. The same pronunciation, sweet. And it is the same thing, it's sweet. So the suite of the for loop is something that starts from the if and ends in the break. The suite of the if is that single statement, true, false is equal to true. The suite of the else is the true false is equal to false, and the break. So what you have in a compound statement, it always begins with a keyword and it ends with a colon. The if itself, even though it is inside the for, is on its own a compound statement. The else is on its own a compound statement. All of that packed together inside the for, all of them constitute one single statement, and it's a control structure. You will get to see how that works, and we will try that. If you have not tried it if you try it in your debugger, if you know how to use a debugger and you have tried it in your debugger, everything will be clear. If you don't use a debugger, you will be talking. If you use a debugger, what we will talk about for 30 minutes will be clear to you in 2 minutes. So just take the code through a debugger, and you will see as you are going through, as the debugger is going through, you will see what is going through over and over, and you see where it jumps and all those things. That will be easy. So observe that after the colon ending the for loop, everything pertaining to the head is indented in a single indent forward. That is called the suite of the for. Everything below the for is the suite of the for. We further observe that if else block here is another block in the loop. Here is the meaning of the code. Pick elements in positive integer one by one. Each time, check if the same element belongs to alphanumeric int. If so, assign true or false. If so, assign true to true false. If not, assign false. And using the break word to end the looping process. That is what is happening here. And you will see the effect of that if you run the code. So I now want to move into another idea. Let's go back again to set and iterables. I've already, in the previous thing, we've already talked about sets. We've talked about set in set theory. We've talked about set in the things you are wearing. We talked about set in the things in your kitchen. We talked about set in the things in your living room. We talked about set in the kind of transport you take to come to school. We have all sorts of things that we have already explained can be used as sets. Now, we want to talk about a general idea which we call iterables. The set collection, as defined in Python, is very close to the set defined in mathematics. Each element is unique in a set. If you add an object already in a set, it simply overrides the previous member. It will not keep duplicates. A set doesn't have duplicates. The elements are not kept in any order. Simple set relationships such as membership, subset, number of elements can be found easily. Python represents a set by surrounding its listed comma-separated objects with braces. If the comma-separated objects are numbers, no quotes. If they are strings, you have to have quotes on each of them, otherwise there will be a problem. A for loop can be used to move from object to object. So let us say we have 10 items inside the set. We may want to inspect them one by one and say what is in the first position, what is in the second position, what is in the third position. Even if you cannot visually see the set, you can tell Python to go and look at it for you and tell you what is there. Now, if you can do that, what if the set contains 1,000 things? The same program will do it. What if it contains 10,000 things? The same program will do it. Your code does not enlarge because the set has become bigger. That is the wizardry of the for loop. The for loop does not have any problem with how many things you have in your iterable. A set is an iterable. Anything that collects items, any collection that allows you to inspect it one by one is called an iterable. And a set, like set we have been describing, is an example of an iterable. We are going to define in today's class 4 different iterables. Set is just the first one we are talking about. There are other iterables that are of importance, and they are fully defined in Python. The beautiful thing about Python is that whereas in languages like C# or C++, these iterables you have at least unless they have changed that in the new ones, you have to define them yourself. It's already part of the language in Python, so that makes life exceedingly object to object. This is moving from object to object in any collection is called an iteration. A collection that has the property of being able to be iterated, where you can perform iterations on, is said to be an iterable. Iterable is a noun now, and that iterable applies to any collection that can be examined one by one. A set is an iterable. So it is important for you when you know you are dealing with an iterable, because it makes life easy. No matter how big the iterable is, you can examine the things that are in it. Three other collections are useful. They are lists, tuples, and dicts. You can see that the colored part of these words are different from the S's I added, because those are keywords. You see, even though I've not told you all the keywords, we are beginning to see the keywords one by one. We will introduce them one by one. These three, just like sets, are also iterable. So a list is an iterable, a tuple is an iterable, and a dict is an iterable. They are definitely not the only iterables. You can create iterables yourself. So it's not any big deal. But these are the fundamental iterables that are already in the language. Currently, we will introduce the list collection. We have seen sets already. Let's introduce the list. In the case of list, whereas sets are denoted by braces, lists are use square brackets or we just say brackets, but we mean square brackets. You use braces for sets, you use brackets for lists. When I say bracket without any qualification, I mean square brackets. If it is the other type of bracket, we call those ones parentheses. So there is no ambiguity. Whenever I talk about brackets without qualifying it, I'm talking of square brackets. So I will not be using square. I will just say bracket. If I want the round brackets, I will talk of them as parentheses. So a list uses brackets. It allows duplicates. It allows multiplicities. And it's also iterable. So you can have many repeats, duplicates, and everything, and they can be indexed. So in a list, you can have the first term, the second term, the third term, which does not apply to a set. A set, you just throw everything in. They don't have any order. Lists are ordered. So we have talked about sets, lists, dicts, and tuples. In these examples, we will come across some of them as we are going on. And if you go through the examples by typing them in and running them, you would have done yourself an enormous good. If you just look, you are cheating yourself, and there's nothing I can't help you. Like, you can only lead a donkey to the river. You cannot force the donkey to drink the water. So I can't force you to drink the water, but if you drink the water, it will do you good. Guiding principles. Several examples and exercises will be given subsequently. There will be a question we are dealing with. If you quickly get the question, you can try to write a program to answer it. If you can't, don't worry. If you can't, compare your answer to the one given, make amendments to your code. That is, after some time, you'll be able to write some code. Like I told you, anybody who can type in 200 codes that are working from another person is already a programmer. So if you want to be a programmer by the end of this week, just go and type in all the codes that I have given to you, make them work. You are already a programmer, and you will be surprised that it is that easy. You will still have a lot to learn, but you are already programming, because some of the patterns of what I am doing would have entered your head, and there's nobody that can remove it if you actually did it. That is the reason why I didn't give you the code. I could have given you the code file so that you can just put and run. But the actual painstaking method of typing it, making mistakes, correcting them, and dealing with syntax error, semantic error, and all the errors, that is actually how you learn to program. Any other way, any shortcut is a shortcut to oblivion. You are not going to get anywhere. So compare your answer to the one given, make amendments to your code. If there are errors, try again. It is a good practice to attempt to write your own code first. If you can, if you're unable to do so immediately, don't be discouraged. Practice makes perfect. As you go along, you will become better. If you fail to write a successful program, make sure you practice by typing in the solution provided and learn the proper lesson before attempting the next exercise, and understand the patterns. Understand the patterns. The patterns are rigid and they don't change. Okay, let us take this is a very simple exercise. Beginning from the list of items Ade is wearing, check if the list of what you are wearing, I've named you Toby, you give your own name, and you now create the set of what you are wearing. And what we are now trying to see is whether there is any intersection between what you are wearing and what Ade is wearing. Or there is no intersection, or so you just, if you type in that code, the only thing you need to change there is the list of what you are wearing. Remember to put them in quotes. So you can continue making that program. If you try, you will know something. If you don't try, you will not learn. So it's up to you. If you try, you will learn. If you don't try, you will not learn. Beginning from the list of items, check if the list of what you are wearing is a subset of Ades, or if it's a disjoint set with it. Recall that if A intersection B is the empty set, in which case there are no elements common to them, the sets are said to be disjoint. And if a set is empty, the number of elements in it will be 0. So we can check whether a set is disjoint by checking how many elements are in it. If the number is 0, then that is disjoint. You will see how to check the elements, the number of elements soon. Beginning from the list of items Ade is wearing, from the intersection between Ade's set and yours, find the intersection between Ade's set and yours. Demonstrate that for any two sets, S and T, the intersection operation is commutative. So if you say S intersection T or T intersection S, you see how Python writes S intersection T, and how it writes T intersection S. You see that the result will be exactly the same. So this is a mathematical statement, not a programming. I'm just explaining mathematics here. So this is not an assignment here, it's equality. So when we are in math, that sign becomes equality. When we are in programming, it is an assignment. Apart from printing these results, create identifiers and assign them. Use the debug facility to check results instead of printing them to the terminal. I'm going to take some specific programs and run them through the debug so that you see, in case you are still afraid to do that and you have not done it, or you have done it, you don't understand some things. I will do some practice, which you will see here. So, exercise 3. Beginning from the list of items Ade is wearing, find the intersection between Ade's and yours. Find here, it's not intersection now. I wanted to say find the union. Demonstrate that for any two sets S and T, the union operation is commutative. That is, S union T is equal to T union S. Apart from printing the results, create identifiers and assign them. Use the debug facility to check the results instead of printing them to the terminal. Now, there is a mathematical expression here, that is the number of items in S and the number of items in T is equal to the number of items in the union and the intersection. So we can demonstrate this with the code. We are demonstrating with the code here. You can see that if Kemi's diet list is pounded yam, barley, rice, dodo, yams, eggs, beans, watermelon, mango, egusi, bananas, pineapples, apples, eggs, and oranges. Now, you now go and write your own list. Here I call it my own. You use that identifier or some other identifier. Put your own list. Okay? So you put your own list there, and using the relationship between the items on Kemi's menu and yours, demonstrate the above relationship. For instance, if you look at line 11, learn Kemi tells you the number of items inside Kemi's list. Learn my own tells the number, returns the number of items inside my own. Union number, you take Kemi union with my own and you take the length there. Intersection number, you take the length of Kemi intersection my own, and then you now check if Kemi plus the number of items in Kemi plus the number of items in mine is equal to the number of items in the union and the number of items in the norm. You can see here on line 15, it is equality. that we are looking for, not assignment. When you are looking for assignment, we want to check if those two are equal. If those two, because on the left hand side a number is produced, on the right hand side a number is produced. That's not an assignment. If it was an assignment, that statement would be in error. I want to go to the chat room. Go and tell me why it will be impossible, it will be incorrect to write line 15 as a statement, that thing inside the bracket as an assignment statement. That would not be correct. You cannot change that double equal to a single equal and write it as a statement on its own. Go to the chat room. I want to see whether you are awake. Go to the chat room and tell me what is wrong with line, why line 15 can never be an assignment statement. So I'm going to go to my own chat room and just check what you are doing there. Go to the chat room. I'm in the chat room now. I want to see why that cannot be an assignment. Why that would have been wrong. Somebody said, Oluwafemi, I'm sure you have already seen that. You have already seen the answer. Okay, so let me see. I want you to tell me why it's not possible. So let help us to count. Yes, of course, because it doesn't have a proper identifier. It has two, because we use two equal sign. No, I'm saying if you change that equal sign to one, it won't work. It won't work because as an assignment operator, because assignment are used when giving variable value. No, that's not the reason. It will give a new value to the identifier. No, that's not the reason. Equal is not an assignment. No, you can change it. Suppose you change it. I'm saying that it will still be wrong, even if you change, because Python will interpret it as textual comment. No, it is not an assignment statement because the double equal sign. No, you can. I'm saying if you change the double equal sign to a single equal sign and you make it an assignment, you are going to get an error. The double equal sign is no. Double equal sign is an equality. Yes, it's a comparison operator. It is not an assignment operator. Sir, can we see the code again? Now, you have nobody got it right. So it is because an assignment operator is used to declare a value to a variable rather than comparing. No, you can't use an assignment. You can't use an assignment operator. You can. Parentheses will let it run. No, suppose you remove the parentheses. You remove the if. You remove the parentheses. That will still not work. Functions are different. No, it will not work. No matter what, with all these things, it won't work. And the reasons you have given, none of the reasons is correct. All your reasons are wrong. So let me go back to the example and begin to do the slideshow from this current slide. And let's see. Okay, here is where there is a problem. This is where you have a problem. You realize that there are two. You need to realize that there are two on the left-hand side. If it's an assignment, on the left-hand side, there must be one only and one assignment, and one identifier. You cannot have a computation on the left-hand side. You can have a computation on the right-hand side, but on the left-hand side, there must be a single identifier that receives the result of that identifier. Nothing else will work. So you understand? Nothing else will work. So you cannot have anything else on the other side. So let me go and see whether some of you have realized that now, because we've been saying that before, and you didn't seem to get it. I want to see whether I've communicated that idea now and you have understood it. So I'm back in the chat room. I've showed you the code again. Do you understand now? Let me see a response. Do you understand why that could not be an assignment? I'm looking at the chat room again. So it's clear. Shotade has responded. Anybody else? Is it clear? Because when you are talking of an assignment, the assignment can only happen where there is a single thing to receive the result of the assignment on the left-hand side. If there is more, if you don't have that, you can. Okay, so that is good. So I'm going back now to date. Okay, so you can see you can see that everywhere there's an assignment, there is only one identifier on the left-hand side. Whenever you do not obey that rule, you are going to get punished. Okay. Okay, so let us go on. So you have to try that out and see the result. Now, the exercise 5 is what I will practice for you online. So in this particular case, you have two lists. Sorry, you have not two lists now, two sets. There's a set which you call author's library. There's another set which you call my list. My list is the list of authors you want to read this month. That's ambitious to read those authors this month. But you go to the library. In a usual library, you may have 1,000 in the author's set. Author's library set may be 1,000, and your list may only be 5. What you want to do is to use one list to check the other. You want to check how many of the books you want to read are in this particular library. The way to do that is to create a dictionary. And you create a dictionary by starting with an empty, just like you create a list by empty brace. Dictionaries and sets are, they use braces to represent them, but they are different. So you can create a for loop. In your for loop here, you can see that the for has the for keyword and the in keyword for author in my list. So it will take everything. Like for instance, it will assign Olabode to author. It will assign UP to author. It will assign Adabu to author. It will assign To to author. It will assign Adiche to author. It will assign Achebe to author. It will assign Shonyika to author. It will assign Wakwo to author. It will assign Bronte to author. It will assign Rakumi to author. It will assign Yinka to author. It will assign Loto to author. It will exhaust everybody inside my list by taking them one by one. It takes one and goes through the entire suite. It will go through the suite one by one. That is called iteration. When it gets to the if statement in the suite, it is going to take the current value of author. It will use it to go to the set in the author's library. If it finds it there, it will say it is available. If it does not find it there, it will say it is not available. And by the time it has gone through everything, it will have a dictionary which will now append Olabode, whether it's available or not, UP available or not, and so on. So it's not going to come back with the set. It's going to come back with a dictionary in which each item in the set has a dictionary value, a dictionary result. And you cannot understand this. I typed this thing in. It took me about 3 minutes to type everything in. Again, I typed it in because the computer I'm using to teach you now is not the one I typed it in through. So you can see this thing. So it's not you can do this thing fast. It doesn't take a lot of time. But if you are lazy and you don't do it, you are going to pay we are going to pay in life. And I'm not cursing you. I'm just encouraging you to do it. So let me go to Visual Studio Code and try out code. Let me open the file. Open. Well, let's see whether it is there. A dictionary example, yes, there. Okay. So this dictionary example is slightly different because I was typing it in a hurry. And I did some things different. But the whole thing will work the same way. So let me just, first of all, stop debugging. I hope you can see my screen. So this is how it will look if you start. So you are going to click run on top there. You are going to click run and you are going to choose start debugging. So when you choose start debugging and you start debugging, and I've already created a break point at the beginning. You just right click and that dot will be there. So it's telling me now it is at the first line. So what I want to do, you see on top here, you either use F10 or you use your keyboard or you use your mouse on top there to click that run F10. So you can step over. When I say step over, you can see it goes to the next statement. Or that means that it knows that everything between lines 1 and 7 is a single statement. So it may occur on several lines, it's still a single statement. So if I click again, step over F10, it goes to my dict. It zeroes my dict. It creates a dict of nothing. It's a dictionary of nothing. By the time you're on 17, it is printing the dictionary. You would have packed it with the result. So let us see what we'll do. You see, I want you to observe what happens in the for loop. So the first thing is it gets the for loop, and you need to see what is happening here. What it calls variables are identifiers. The variable is recognized now. It knows that my dict has nothing. It knows that my list has a number of things. You remember that my list has Rakumi, Nwankwo, Ngugi, Yopi, Wole Soyinka, Lotto, and all those ones. Those are the things in my list. There are 14 things in my list here. They may not be the same in the list you have in the text. If you go down, you can see the author's lib has how many things? Has a lot of things. Has 28 entries. It has 28 entries. So those are the identifiers and their values right now. My dict has nothing. My dict is a dictionary. It has a length of 0. But my list has a length of 14. And this other one has a length of 28. So those are the things that are inside this place right now. So let us observe what happens when I step into the for. If I press F10 or just click once here, you can click once. It is interesting to see what value the author here now has. Let us go and see whether it has a value or not. Let us see. Inside that loop, cannot see. My dict, special variables, function variables, length, author library. Okay, let us see. Is it a global? No, it's not global. Nothing yet. So let us step again and see whether there's any value change. So you can see the author it picked is Rakumi. You can see now it has picked author to be Rakumi. So it is picked the first thing listed there, and it's going to compare it to everything in the other place. When it got here, it could not find it. It could not find it in the author's lib, so it jumped to the second one, and is now going to type not available false into it. So let us see. So when we step over, it has gone back to pick another one. So what did it pick next? It picked Nwankwo. Let us see what it picked next. Nwankwo. So you can see that it's not going in any order. The first thing it picked was Rakumi. The next one is Nwankwo. When you have a set, you cannot predict how, because the things in a set are not in any order. Even the order you wrote, it doesn't obey them. So it's now picking Nwankwo. You can see Nwankwo is the new value. It's good, but it's going to make sure it iterates through everything. It will pick 1, 1, 1, 1 until it picks everything. It will not make any repeat. By the time it picks everything, and it's going to compare them into the other one. And as you are clicking, you will be seeing the way these things work. As I'm clicking, sometimes it goes to the else statement, sometimes it stops at the if statement, sometimes it goes to the else statement, until it goes through until it takes everything there and is able to find information about them. So if at this point, if we go to look at my dict, let us look at my dict. My dict that started with 0 already has several things. It already has 11 entries. It has, for instance, but it is not like the set. My dict here, Rakumi has not available false. Nwankwo has available true. Ngugi has available true. Jopi has not available false. And so on. That's a dictionary. It's not a list. Sorry, it's not a set. You can see the difference between a set. A set is an annotated, a dictionary is an annotated set where there's a description on each of the items in that set. That is what you have a dictionary. You know what happens in your dictionary. It's not just a pack of words. It's a word with something written that can be helpful about that word. In particular case of the dictionary, it is the meaning of the word. But as long as there is an identification of one thing with the key entry, it is also a dictionary in the general sense. You can see how good this is. If you can go through this iteration, you know how the structure of programming is carried out. By the time it finishes everything, by the time it has finished from lines 12 to 16, which it does iteratively, it goes until everything in the list is examined. After everything in the list is examined, you can now go to 17 and print the availability list, my dict. So let us run that and see what happens. So if you go down to the terminal, you will see this thing I'm going to mark. You go down to the terminal, you will see that in the availability list, it has said availability list: Rakumi not available, Wanko available, Ngugi available, Jopi not available, Wole Soyinka available, Loto not, and so on. This is obeying the order in line 17. That's why it brings this out. So you have two ways of knowing what's going on. You have the debugger, which is the powerful one, and you have the response to your print statement, which is what we have seen here. I will leave it like that. You go to your what do you call it now? You go to your chat room and make comments, ask questions. But I'm telling you again, and I will keep telling you, if you do not practice this thing, if you not type this, look, what do you have to lose? Just type this thing into your Visual Studio Code and run it the way I've just run. What is so sacrosanct about what I have done? What have I done that you couldn't do in the comfort of your home? Why? Why would you cheat yourself? If you do this, the enormous gain you are going to make, you will see tomorrow when we start writing code to create graphic elements. You will see how useful the discussion we have had here, you will see how useful they are. But go to the chat room, write more questions. I will give you up till 11, 15, 11:16 to come back. So you can take a break now and come back at 11:16. In the meantime, I'm going to go to the chat room and see what you have been writing. Okay, the next exercise is doing a Venn diagram. I'm sure some of you will be excited at the fact that you can do some more Venn diagrams. But the problem you may have is even though there are libraries that may not be present in your installation because they don't come naturally with Visual Studio Code or with your Python itself. It is an external library. You will have to install Matplotlib. You also have to install Matplotlib Venn. Matplotlib does not contain the Matplotlib Venn. You do not have both. You are going to receive errors on those inputs. So I will show you how to get those things into your system if you do not yet have them in your system, because that's why you have errors here. I have them in my system, so I don't have errors. So you can check this exercises here with Venn diagram, listed authors, my own list, the intersection of that. So, and then I introduce next on page 80, I introduce to you the issue of comprehension and interval sets. In order to introduce intervals for you, I want you to note there are some mathematical rules here. For instance, if you want the range 0 to 20, and if you write it in parentheses, both sides, it means that x is greater than 0, less than 20. So that means that 0 and 20, that is the boundary of that set, is not part of the set. If you do it the second way, you have parentheses in front and brackets at the back. Then it is x greater than 0, less than or equal to 20. So that means that the upper boundary of the upper part of the boundary is included, but the lower part of the boundary is not included. In the third one, the lower part of the boundary is included, but the upper part of the boundary is not included. And the last one, you have a set that contains all the elements within and also the elements on the boundary. That is how, but that is just mathematical symbolism. That is standard. It's not me that did that. That is how all mathematicians write. That is the general mathematical way of writing. In Python, as well as other programming languages, we distinguish between integers and floating point numbers. For example, the first 21 integers are members of the set 0 to 20. There are infinitely many numbers between 0 and 20. This interval can be written as shown on the right. Numbers such as 4.25, 19.6, 22.85 are known as floats, whereas the integers values are ints. So I've talked about import libraries. Some of the libraries we installed at the beginning of this course are Matplot library Ven, and Portion. If you have not yet installed them, you need to use the terminal and use the pip packaging to install them. I've supplied again the code to run. Comprehensions themselves are built into Python programming and can be constructed with basic installation without needing to import modules. In the ensuing code, we generate postint as well as intervals as we previously described. The code went further to check the set for membership and specific elements. So you have to be careful when you are working with numbers that are integers and when you are working with numbers that are a real number, which is called float in Python. Well, this particular code will not run unless you have Portion and which you can install. And I'm not going to display this. I'm not going to demonstrate this for you. I want you to, but if you do not have Portion, you are going to be flagged errors on line 1, and you may be flagged errors on line 2 or on line 3. If you have difficulties with that, what you do is shown in this piece. You launch a terminal from your Visual Studio Code IDE, and you can type pip install Portion. It will install Portion. If you say pip install matplotlib/ven, you must have internet to do the installation. So, and then if you want to install matplotlib, you say pip install matplotlib. But usually, I think matplotlib may have come with your environment. But if it doesn't come, notice that when you are installing it, it is a dash. When you are using it, it's an underscore. So you have to be careful. This course will install the required libraries in your Python environment. But if you have several Python environments, then you have to be sure it's installing into the one you are using. Otherwise, you may have it on your computer and you are still having errors. So, union and intersection of intervals. Sets, as we have seen, can involve discrete element comprehensions as well as intervals. The above code demonstrate clearly how these can be put together and create discrete and continuous sets. We can use the same set relationships such as unions and intersection for operations on discrete and continuous sets. Simple results of unions and intersections are shown. You will have to now go and be running the codes I've given you. I've done enough for you. I've given you the codes. I've made sure they work. And it is for you to test them under a debugger so that you understand the specific things that we're asking. If you have difficulties after you have tried, then let me know. I will explain more. These are questions that came out from YSSCE. Again, they are not difficult things to do manually. I'm just writing them with the program to just show you how you can actually use program to do many of these things. So it is to use what you know to teach you programming. The easiest way to teach anybody programming is what they know. And people are asking me about YouTubers and all those ones. I've seen a lot of what people do on YouTube, and some things are quite useful, but some things are counterproductive for your situation because you are university students. So, university students, when we deal with an engineering student, like for instance, if I'm teaching an engineering student FreeCAD, I shall be able to assume that he knows geometry. So when I'm dealing with geometrical things, I don't start wasting words. But if I'm talking to an Agbero in the motor park, I cannot assume he knows geometry. I cannot assume he knows calculus. I cannot assume he knows what the differential is. I cannot teach like that, because if you teach like that, this rate at which you can move is so slow. So, like for instance, some of the examples I gave you, I got some of them from the YouTube. But the method, if you look carefully, you see that we didn't use the same method, because the method they are using is sometimes so flimsy and so error prone. Whereas if you can script some of these things, they cannot assume you can script, because they don't know where you are coming from, whether you know Python. But because I'm teaching you Python, I know you will know Python, so I can do that. So they don't have the same it is is what they can assume. It is not. There are two issues with the people on YouTube: one, their background, and two, what they can assume. There is a limitation. A non-engineer cannot teach you what I'm planning to teach you in FreeCAD. It's not possible because I am trying to train you to use FreeCAD to generate graphics that we use in engineering simulation. The person talking on FreeCAD doesn't even know what engineering simulation is. So how will it teach you that? And then the result of what it teaches you may not even work for an engineering simulation. I will discuss some of that tomorrow. So use people on the YouTube to help you if you have difficulty with fundamental things, but they cannot replace what we are trying to do here. So we can continue on this. You can continue play with the code. I don't want to stop on this because I want you to take these things as things for you to practice. All the codes that I've written here, if you practice all of them, you are already in good. You are already in a good shape. So let us talk about string literals str. You may have noticed that when we use string objects in our set, we always place them inside within apostrophes and quotation marks. When we use numbers, we do not usually do so. You will see occasions later when we shall place numbers in quotation marks. Strings of characters within quotes is a type in Python. The name of the type is string, str. All the food items in the membership sets and GK that we have done are of type string. These are the string of literals in your code. Because they are in quotes, except for a few symbols with special meaning, you are free to place anything you like inside the quotes to make a string literal. Once you have placed it inside quotes, there is no danger of wrongly interpreting it as a variable or a keyword, even if the names are identical with either. Python allows for three types of decimal numerics. They are int, float, and complex. Ints are members of the natural numbers. Floats are real decimal numbers. Complex are written in the form x plus yi or x plus yj, where x is the real part and y is the imaginary part. You can find the type of any value or identifier referencing it using the type function. If you put the name of an identifier inside type function, you will know how Python is treating that identifier. Now, what does it matter? How Python treats the identifier is going to determine what operations it can carry. For instance, if you put 12 in quotes, that 12 is a string. You cannot add it because the only arithmetic you can perform with a string is concatenation. For instance, if your first name is Ade and your last name is Chike, so Ade Chike, which is your full name, can be done by adding Ade plus Chike. That addition is not arithmetic addition, it's called concatenation. It is concatenation you can do with string. You can also find out how many elements are in a string and so many other things. You can arrange them in order. But if it is a number, you can do addition, division, subtraction, exponentiation, and so many things. So once you have placed it in quotes, you have robbed it of the ability to behave like a number. It's now a string. So if you want to make it a number back, you have to do a conversion. So the type will tell you, because the type of an identifier determines what operations are valid on the identifier. You cannot divide 20 with Chike. You know that's not possible. And the computer will enforce the rule and flag you an error if you ever try to do something that's silly. So that is the thing. So the type of identifier is very important. I'm still talking about testing of things here. I don't want to go. I want to move to on page 106, where we talk of types and classes. Python is an object-oriented programming language, and many people don't know. And because Python is so good that it can pretend it is a procedural language, and you can use it for a long time thinking you are using a procedural language, but Python is fully object-oriented. One of the salient features of an object-oriented programming language is that you, the programmer, can define new types in addition to the built-in types supplied by the interpreter and the programming environment. The difference between a class, the types you define are called classes, the other ones are called types. The difference between a class and a type is not what they are, but how they are created. A class is a type is a class. They are all the same. But the type is what we call it when the compiler creates it as part of the language. The class is what we call it when you or another programmer creates it himself. But whichever way they create it, the beauty of an object-oriented programming language is that they are both first class. So it doesn't matter whether you are using a type or a class, the same rules apply to both of them after they've already existed. The only thing that differentiates them is how do they get born? How do they come to life? When the type is built in, it is usually called a type. When it is defined by the programmer directly or imported from programs written by others, the name of such types is called a class. The two words are used interchangeably, as you can see when we are asked for the type of a string. It tells us it is of class string. So notice that class means type means class, except that type is part of the fundamental language, but class is what you add. So collection classes. The set is one collection class, and there are others. They are list, date, and tuple. Each collection class is also iterable. I've explained that in the sense that the items contained can be examined one by one. They can be used in programming constructs that require iterables. An example is if if or a for loop. Sorry, there's something wrong there. A for loop takes an iterable and performs each cycle using items of iterable one by one until it has done so for all the items in the iterable. The order is the indexing order for a list. It is arbitrary and unpredictable for a set. So if you want a predictable order of referencing of iteration, then you have to convert your set to a list, which you can easily do. A set is a list can be populated by the elements in a set. Once it is populated by the elements in a set, its elements are now ordered and the iteration process is clear. And you can also, just like you can turn the elements of a list into a set, you can turn the elements of a set into a list. But if you turn the element of a list into a set, all the duplications and multiplicities will vanish. So it will, because the set does not tolerate repeat. How do we tell Python about the type we are using? Python gets to know types by inferring the value created the first time the type is used. So Python makes inferences. Python knows, for example, that Olu and Chike in previous programs are set of strings because in the first allocation of value, a set of strings is assigned to it. Python knows that test1 and test2 are bools. They are Boolean. For the same reason, a Boolean is something that can take only true or false, or male or female, or yes and no. It's just two binary. So for the same reason that the expressions which they were first referenced are Boolean expressions. There's another program here. Again, I'm not going to do this for you. It is for you to run this program, see what it does, and see whether it helps you to understand some things about programming and programming in Python. We give a more formal description of the Python script to conclude the first chapter of this course. It will draw heavily on concrete examples we have already seen. We shall refer to the Python official reference for further reading. So if I'm going to give you things to read, I'm not going to direct you to YouTubers. I'm going to tell you to go to the Python official reference, which you can see from this place. That is authoritative. Let me warn you, there are erroneous things on YouTube. So any Tom, Dick, and Harry can go and put something on YouTube. If somebody lies on YouTube and he can draw enough crowd, he will be okay. So there are things you should be contacting official references, official guides, official programs, official papers. But I'm not saying that YouTube is not good. There are fantastic people on the YouTube, and there are things I personally learn on YouTube. But what I'm saying is that YouTube, you have to take it with a pinch of salt. It doesn't necessarily, it can be very slow because it is addressed to the whole, it's addressed to the packed out as well as intelligent people. If you are on YouTube I cannot teach you Python the way I'm teaching you, assuming you know sets, because you may not. But how can you get a place in system engineering in Unilag, except you already know what sets are? Those you would have had to go through the crucible in JAMB, in SchoolSat, and all those things before you can get where you are. So I know the kind of people I'm instructing. So I cannot write something like a YouTube video that is addressed to the general population. If I'm writing, it is addressed to a special niche population. And therefore, we can learn faster. As before, never assume that you understand any concept until you have written your own code using that idea. It is a good start to copy and run given code, such as examples in these lecture notes. Reference materials as well as other things you may find on the web or elsewhere. If you go to the Python official reference, you will see programming fragments there. Those ones are they are fireproof. They will work and they will do the correct thing. Success comes when you have sufficient understanding of the concept that you can write code with the concept. Python language allows you to write scripts that are parsed and executed line by line. Ordinarily, a statement will be executed before others that succeed it. That is ordinarily. The control of flow in a Python statement starts from the first statement and moves to the next until all the statements are executed. That is called the normal control of execution. Reasons, and sorry, the above description needs to be taken with a pinch of salt for two reasons. There are compound statements, and some of these compound statements are control statements. The duty of a control statement is to alter the flow of execution. That is when you execute a control statement, it alters the flow of execution. That is its job. So even once the control statement is executed, the flow of control is altered. A simple, now we are on page 112. If you just followed by listening to me, you are not going to understand what's going on. But if you have struggled through typing these codes and running them, you have deeper understanding at this point. Because the reason why I put a lot of code ab initio in the front is that I know that the pattern recognition, the patterns you have created will help you to understand when I begin to now make format statements of teaching the language. In the first 100 pages, I wasn't teaching the language. I was just trying to push you into the deep end of water. You see, it's just like you are giving somebody, you want to teach him to swim. I'm not going to tell you whether I know how to swim or not, but let me tell you how you teach people to swim. You see, when you want to teach somebody to swim, you throw him in the deep end of the pool, making sure there are people to save him if he wants to drown. He will struggle to come out. After some time, he too will want to jump to the deep end of the thing, because if you sit him in a class and you are teaching him, okay, when you swim, you move your hand like this, you move your leg like this. Teach him for 10 years, he still cannot swim. It's like, again, teaching somebody to play the piano. And you take a course piano 306 in Unilag, and the lecturer comes and says, the piano, when you press the key on the left side, it will sound ding. When you press the one on the right hand side, it will sound do. And you continue teaching that person, and he gets a first class in music. He still cannot play piano. He has first class. That is for his pocket. He cannot play piano. So if it doesn't matter whether it's piano, it's music, or whatever, it goes the same way. So there are some things that can only be learned practically. If you want to know how to drive and somebody sits you in a classroom without taking you on the road and is teaching you to drive, is deceiving you. So once you have learned some driving, once you have been forced to move a vehicle, move it on the road, then you can come back to class and we can teach you more theory. So that's what we are doing here. So those of you who are at page 112 of my slides and you have not actually practiced the programs, you are cheating yourself. You are cheating yourself, and you are not really doing yourself a lot of good. And I will tell you, if you get tired of my telling you, fine. Those of you who have tried, you know what I'm talking about. So let us talk about simple statements. A simple statement ordinarily begins and ends on a physical line. Ordinarily begins and ends on a physical line. When this happens, a physical line is also a logical line. We already saw code here in the earlier slide where every statement is simple and they occupy single logical lines. Here, statement 1, statement 3, statement 11, and statement 13 are broken statements. But they are still simple statements. They occupy more than one logical line. So they occupy more than one physical line, but they are still considered one logical line because if you have a wide enough screen, you can put them on a single line. The only thing is that you break them when you are doing that, you break them. Python will show you that they are still the same statement. You can see in line 2, it shows you that line 2 is a continuation of line 1. It shows you that line 4 is a continuation of line 4. And line 3, line 12 is a continuation of line 11, and line 13 is a continuation of line 14. When you break at a comma inside a set, or you break at an operator in an expression, that break is natural. But you can force a break and break anywhere, and there is a way to do that. So you want to convert a single logical line to two or more physical lines. There are ways to break. And the way to break, let's see, oh no, it's further down. I will show you that because I don't want to miss some things. Each statement is an arithmetic assignment. We may get the impression that simple statements should be assignments. No, they don't have to be so. We can break statements from line 11 to 12 into simple statements as follows. We can write the statement in line 11 to 12 can be broken into 3. And the statement test 1, you can write test 1 is equal to A and equal B. That is a correct statement. It is correct because of there's something called operation precedence. Operation precedence is what you learned. What class were you when you learned BODMAS? Would you be in primary 3 or primary 4? You remember when you learned BODMAS? When you learn BODMAS, you know that if there are operators on the line, there are automatic precedence rules that you use. In programming, there are precedences and associativity. When you combine the two of them together, they are BODMAS on steroids. They are more than BODMAS because in BODMAS, you are dealing with 5 or 6 operators. In some programming languages, you are dealing with 20 or 30 or 40 operators. So when you have to cope with that, then you are dealing with a lot of things. So you have to have operation precedence, and when classes of operations are in the same level of precedence, then the associativity takes place. The associativity becomes the issue. For instance, if an operator, if an expression associates from left to right, then if the precedences are the same, the one that is on the left will have precedence over the one further down on the right. If the associativity is from right to left, the one on the rightmost one will have. In this particular case, in the case of test 1 is equal to A is equal to B, what happens is that the equal has a higher precedence over the assignment. So it will first of all compute A equal B, and it will return whether true or false. And it is that true or false that will be stored in test 1. So test 1 will be a logical operator, whereas A and B can be anything. A can be a number, can be a string, can be anything, which must be the same as what B is. But the result of this comparison of equality will be stored in test 1. So, and it will be a logical operator. So that is what is happening here. The third of this statement is a logical comparison, ignorable, and it's a statement nevertheless. In the above example, we have seen simple statements and expression statements. Any computation or expression can form an expression statement. This includes function calls, which is the same as whatever the function returns. A return statement is followed by an expression, and it is the computed value returned by the function that contains it. We'll get to functions later. A break statement, as we saw previously, transfers control to the statements following a looping statement. A pass statement is logically a redundant statement that does nothing. But it's a very useful statement, even though it does nothing, because when you are debugging, you can set your breakpoint on it. Whereas there are places where you cannot set your breakpoint. So a pass statement, redundant as it looks, can be very good, can be very useful. A continuous statement in a loop immediately goes to the next iteration cycle. So if you get to a continuous statement, it will not wait until it gets to the end of the loop. It will just go back. We've already seen the use of import and from statements that we use to bring external libraries into scope and use in our current running program. Other simple statements will be introduced by usage in due course. Note that simple statements occupying more than one physical line can be made to occupy one physical line. One would only suffer the inconvenience of scrolling horizontally to see the end of such a statement. So, like instead of what we wrote before now, we can have these statements here, in which case every logical single is also a physical single line. So that is possible. Implicit and explicit line joining. That is what I was trying to tell you before. The use of multiple lines to represent single logical lines that we show here have the same meanings. You can see that on the upper side, we are using natural breaks like commas inside sets. On the other side, we are using the backslash. The backslash, you can break anywhere when you are using the backslash. It doesn't matter whether there is a comma, whether there is an equal. When you break, the logic of the something will pieces those things together into a single line, and there will be no problem. So you can test those out. In the first case, we have been careful to break the lines at commas and thus create implicit line continuations. Those are implicit line continuations. We can implicitly break logical lines to multiple physical lines using other punctuators. In the second case, we use the backslash character, which when used in this way, we have forced the line continuation explicitly. Doing this in this way allows us to break the line at will. It will not matter whether there is an operator or a punctuation mark. A compound statement is different from a simple statement. A compound statement physically and logically appears on more than one line. It has clauses. Each clause begins with a header and ends in a colon, and it's followed by a suite, which is a block of statements, simple or compound, that are indented. The execution of this compound statement is controlled as determined by the logic of the header in each suite. It is more instructive to look at specific cases of compound statements, such as looping controls or conditional statements. We cannot talk generally. And compound statement can contain simple statement. It can also contain compound statement. But when you are putting a compound statement in another compound statement, there must be no cross-linking. So if a compound statement has several clauses, the clause must begin and end inside a suite. It cannot cross-link between suites. If it does, you are just complicating matters, and you are going to be rewarded with error messages. Python code executes statement by statement. There are blocks of statements that create control sequences. It is correct to say Python code executes statement by statement. Two kinds of controls are important to consider at this point: looping controls and conditional statements. We will use example of codes that we have already seen to explain this in simple terms. If-else block. If-else block allows statements in a block to be executed or not executed depending on the result of a Boolean expression that is in the main heading. For instance, in this case now, if 12 is an int set. So if 12 is found in int set, it will print 12. It's an element. If it's not found there, it will print it is not. So which of the suits will be executed depends whether that first logical thing is true or false. If it is true, it will execute the clause, it will execute the suite in if. If it is false, it will execute the suite in else. Remember that the suite in if, even though there are simple statements here, they can be 1,000 lines long, each of them. So there is, and they can contain other ifs, other statements, but they must be indented with respect to their headers. So these are just simple ways to express it. It can be much more difficult, complicated than this. And if you understand the logic, you'll be able to read and interpret any code. The print statement we executed depends on the expression, the result of the logical expression. There are two clauses. Each suite is a single print statement in this case. Here, you have another if statement with three clauses, three suites. So there are three suites here and three clauses. The condition block here has three clauses, each with its own suite. There are two conditions. If the first is true, the pre statement is executed. The second statement is checked only if the first statement is false. In that event, the second statement is executed given that the first is false. The last statement is what gets executed if both earlier conditions are false. In a conditional statement, control is relinquished to the statement following the block once any statement is executed. Conditional block. Even though, as I am going on, I am sure you will see that if this is what I started with, you'll be bored to death. So that's why it is always good to have your hands wet. Jump into the deep end, swim yourself out, and then continue to use those as the fodder for learning how to program. You cannot learn how to program in vacuum. Even though we have simple print statements in the suite of the if else block, we can have any number of statements, and they will be executed sequentially if their condition, as stated above, is met. The logic is consistent. Now, we have looked at conditional statements, and we now looked at the looping statements. You can see we did a looping statement first earlier. Again, if you run this through a debugger, it will explain to you better than any human or any YouTuber can explain. In this case, a list is iterated by picking its elements one by one until there is none left. For each pick, the statement block, which in this case is the if-else block, will be executed as previously described. The block ceases once there is an iteration, once the iteration is complete. The suite of the looping statement here is the conditional statement. And the conditional statement has its own suite. So you have to be very careful and see that the logic is very easy. Break it out of a loop. The break statement, when encountered in a loop, terminates the loop and passes control to the statement following the loop. It will abandon everything in the suite and will just go out of the loop. This is an example in the previous program. The break statement, with the break statement, the iteration ceases immediately, and other cases will not be considered. Imagine we want to count the alphabets in a sentence. Again, you have no choice. You have to run these two programs to understand what I am saying here. If you do not run them, you will not get much out of it. Just go run these programs, counting characters in a sentence. There are two ways given here, and you would be able to tell me which one is better. One is slightly longer, but doesn't mean anything. The def statement. Well, I want to stop here.